Students, in the previous class we have proved the Pythagoras theorem. So now in this class we will see the converse of the Pythagoras theorem and problems on Pythagoras theorem also. Students, recall the statement of the Pythagoras theorem. Can you tell me the statement of the Pythagoras theorem? Because it is an important theorem, so which way we play important role in our day-to-day life also. By knowingly or unknowingly, we are using that Pythagoras theorem. Come and tell me, students, the statement of the Pythagoras theorem. Yes. So in a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. Repeat again. So in a right angle triangle, square on the hypotenuse is equal to the sum of the squares on the other two sides. Now it was proved by mathematician Pythagoras. Now we shall see the converse of that Pythagoras theorem. So the statement is, in a triangle, if square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the first side is a right angle. Right? First we will understand the statement of the theorem. In a triangle, if square of one side is equal to square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the first side is a right angle. That means we have to prove by taking a triangle. So in that triangle, if we square any one of these sides, so that square will be equal to, if that square will be equal to the sum of squares on the other two sides. The sum of squares on the other two sides. So then the angle which is opposite to the first side. So the angle which is opposite to the first side is always 90 degree. That means it is a right angle. So before going to simplify this, so understand the statement and with the figure. So if I have taken here ABC as a triangle, so ABC is a triangle. Here, if I take the first side is AC, the square of the first side, that means AC square. The square of the first side is equal to the sum of the squares of other two sides. The sum of the squares of the other two sides. Which are the two sides? Observe here, AC is the first side. So this is the first side. So other two sides are AB and BC. The square of the sum of these two sides. So that means AB square plus BC square. So AB square plus BC square. So if this holds good for the given diagram, then we say that the angle opposite to the first side is always right angle. That means its measurement is 90 degree. Its measurement is 90 degree. Students, I think you have understand the statement with the that. Now we shall prove it step by step. Okay. For proving that, so I have taken a triangle ABC. Triangle ABC. So consider the triangle ABC. So according to the statement, the data is in a triangle ABC. In a triangle ABC, if AC is the first side, if you consider AC is the first side. It is the first side. The square of this side, AC square, is equal to the sum of squares. The sum of squares, AB square plus BC square. The sum of squares of other two sides. That means AC square equals AB square plus BC square. Yes. So this is the data in triangle ABC. AC square equals AB square plus BC square. So what we have to prove here? We have to prove that the angle which is opposite to the first side. AC is the first side. Therefore, the angle opposite to the AC is angle B. So this angle should be 90 degree. Therefore, the proof is angle ABC equals 90 degree. Angle ABC is equal to 90 degree. So this is not enough data to prove the theorem. Therefore, we have to make construction. What we have to construct? Here we have to construct another triangle PQR. We have to construct another triangle PQR, right angle at Q. Right angle at Q. So here that means we have to take the right angle triangle. So that means we have to construct a right angle triangle such that the length of the sides PQ is equal to AB and QR is equal to BC. PQ is equal to AB and QR equals BC. Now students, we will construct the triangle PQR. So that is a right angle triangle. So first triangle is not a right angle triangle. It is not confirmed. But so in the construction, what we have taking another triangle. So it should be a right angle. It should be a right angle. Now students, I am drawing a right angle triangle. Right angle triangle. So call this as PQR. PQR is a right angle triangle which is so here the angle Q should be 90 degree and the sides are so this PQ should be equal to AB. PQ, the length of PQ should be equal to length of AB and length of QR is equal to length of BC. QR equals BC. This is the construction. Now students, so the next part is proof. Next part is proof. So by in this triangle PQR, so this is a right angle triangle. So if we got the right angle triangle, so it is easy to apply a Pythagoras theorem for the given theorem. Therefore, in proof, in triangle PQR, so Q is 90 degree. Q is 90 degree. So therefore, apply Pythagoras theorem. According to only statement of the Pythagoras theorem. The square on the right hypotenuse is equal to sum of the squares on the other two sides. Therefore, we can write PR square is equal to PQ square plus QR square. PR square equals PQ square plus QR square because angle Q is 90 degree by Pythagoras theorem. So now students, so observe this. RHS, observe the RHS of this PR square equals PQ square plus QR square. So in place of PQ, we can write AB because in the construction, the length of PQ is always equal to length of AB. Similarly, in place of QR, so we can write BC because QR is equal to BC. Substitute these values in this equation, we will get LHS remains as it is. PR square equals PQ square. In place of PQ square, it is AB square plus in place of QR square, it is BC square. So call this as an equation number 1. So therefore, this equation will be converted to PR square equals AB square plus BC square. But students, so by data, we know that AC square is equal to AB square plus BC square. From data, AC square equals AB square plus BC square. Call this as an equation number 2. This is from data, this is from construction. So if you observe the RHS of the both the equation 1 and 2, RHS will be the same. So if RHS are equal, then the LHS part is also equal. So the things which are equal to one another are equal. So therefore, we will write so AC square is equal to PR square. So that is the LHS part. In the LHS both sides square is same. So if we can easily remove the square, we will get the length of AC is equal to PR. The length of AC will be equal to PR. Now students, so the last part of the theorem is, so we are going to compare these two triangles. So compare these two triangles and we will show those two triangles are congruent. Those two triangles are congruent. So in triangle ABC and in triangle PQR, the length AB is equal to length PQ. AB is equal to PQ is from the construction. Similarly, length BC is equal to QR. BC is equal to QR. It is also from construction. So and we have proved AC is equal to PR. AC is equal to PR. So that is I have written from the both the triangles. AB equals PQ, BC equals QR. It is from construction. AC equals PR. What we have proved here. So observe this from this. If in two triangles, if all the three sides of one triangle are equal to the all the corresponding three sides of another triangle, then those two triangles are congruent. Here, students, remember here we are going to use the congruency of the triangle, not the similarity of the triangles. Congruency of the triangle. So, therefore, from the axiom, if S axiom. So if three sides of one triangle are equal to the corresponding other sides of the other triangle, then they are congruent. From S axiom, not similarity criteria. So therefore we can write angle B is equal to angle Q. Angle B is equal to Q. Or we can write angle A equals angle P. Or we can write angle C equals angle R. Because they are the corresponding angles or corresponding parts of the congruent triangles. So therefore angle B, we will take just angle B is equal to angle Q. Just we will take angle B is equal to Q, because we have to show that these two are the right angle. B is equal to Q, but the value of Q is equal to 90 degree. So it is from the construction. Therefore, if Q is equal to 90 degree, B is also equal to 90 degree. Hence the proof. Students, I think you have understand how to do the honors of the Pythagoras theorem. Now students, we will simplify the problems on this Pythagoras theorem and converse of this Pythagoras theorem. Okay students? So in the exercise 2.5, first man, sides of triangles are given below. Sides of triangles are given below. Or given below. Determine which of them. Determine which of them are right angles or right angle triangles or right triangles. Right triangles. In case right triangle, in case of a right triangle, write the length of hypotenuse. Length of hypotenuse. Sides of triangles are given below. Determine which of them are right triangles. In case of a right triangle, write the length of its hypotenuse. Length of its hypotenuse. So the problems are, first one is 7 centimeter, 24 centimeter, 25 centimeter. Second one is 3 centimeter, 8 centimeter, 6 centimeter. Third one 50 centimeter, 80 centimeter, 100 centimeter. Fourth one is centimeter. So by observing the sides of three sides of the triangle, so if we apply the Pythagoras theorem, it holds good for the any one of the problem, then we can write it as a right angle triangle. Now we shall check one by one. So first one is 7 centimeter, 24 centimeter, 25 centimeter. Now, if you observe the measurement, which is the largest length of the side of a triangle? Yes, 25 is the largest side of the one triangle. So, according to the Pythagoras theorem, the square on the largest side or square on the hypotenuse is equal to the sum of the squares on the other two sides. So now if we square now square the sides, we will get, so 25 square is equal to 625. 25 square is equal to 625. So 24 square so equals 576. So another one, 7 square is 49. 7 square is 49. So now apply the Pythagoras theorem. 25 square, that means the sum of these two, 24 square and 7 square, that is 576 plus 49. So add, so 9 plus 6 is 15, 1 carry, 8 plus 4 it is 12, 1 carry, it is 625. So therefore we can write at 625 is equal to 576 plus 49. So that means 25 square will be equal to 24 square plus 7 square. 25 square is equal to 24 square plus 7 square. That means the sum of the square of the other two sides is equal to, if the sum of the squares of the other two sides will be equal to the square of the largest side, then we can say that so it is a right angle triangle, because it holds the statement of the, it holds good for the statement of the Pythagoras theorem. So therefore it is a, therefore it is a right angled triangle. Right angled triangle. It is a right angle triangle. So that means the given measurement forms a right angle triangle. So in the problem, if it is a right angle triangle, we have to write the length of its hypotenuse. Length of its hypotenuse. So in a right, we know that in a right angle triangle, so the largest length is called as, or the side which is opposite to the right angle is called as the hypotenuse. Hypotenuse is always the largest side in a right angle triangle. So again, therefore, the length of hypotenuse, the length of hypotenuse this problem. So if you take any problem, so square the largest side. First square the largest side, and by squaring the other two sides and add them. So if the square of the other two sides will be equal to the largest side, so then it is a right angle triangle. So if it is a right angle triangle, the largest side is the length of the hypotenuse. Otherwise, if the largest side is not equal to the square of the largest side is not equal to the square of the sum of the other two sides, then it is not a right angle triangle. So I will give a clue for the second problem. Just clue for the second problem. So second problem in the second problem, so the measurement of the each length is 3 centimeter, 8 centimeter, 6 centimeter. So if you observe, which is the largest side here? 8 centimeter is the largest side. So if you square it, 8 square, you will get 64. 8 square is 64. So now add the squares of the other two sides. So that is 3 square plus 6 square. So it will be equals 3 3s are 9 plus 6 6 are 36. Which will be equals 45. 45. So the square of the largest side is 64, whereas the sum of the squares of the other two sides is 45. So therefore 64 is not equal to 45. 64 is not equal to 45, or in other words, so we can write 8 square is not equal to 3 square plus 6 square. 8 square is not equal to 3 square plus 6 square. So it is not a right angle triangle. So it is not right angle triangle. Okay, students, similarly, we check this in your in your book. So, and you have to be perfect in the theorems, that is Pythagoras theorem, and also converse of the Pythagoras theorem. This is an important theorem for the examination purpose. So, we will see in the next class.